Nice.
Yeah, hello and welcome. I'm Thomas Haddad from University of Duisburg, Essen. We are today here in GeMiC conference, standing in front of the TERAOPTICS booth with Professor Guillermo Carpintero. We would like to have a short talk with him about his role in the TERAOPTICS project, and also talk a little bit about the activities of the student in this, the PhD student in this secondment.
Professor Carpintero, thank you for being today here with us. I would like to start.
You're very welcome.
I would like to start by asking you about your role in the TERAOPTICS project.
My role in the TERAOPTICS projects, actually I'm the principal investigator in Madrid, one of the university partners. So I'm supervisor of 2 ESRs, and as well I'm the secondment coordinator in the project.
Secondment coordinator. First, what the meaning of secondment?
Okay, secondment is a period that the fellows, the ESRs in the project spend abroad. They are hired for 3 years within a main site, the host, but it's a network. There are other partners that are working in the field, so they have the opportunity to spend some time in other partners. It's basically like the Erasmus exchange in universities. Yeah, you basically are hired. You do your degree in an institution. So what's the purpose of going on an Erasmus exchange? There are reasons. There are personal and academic reasons. So in this case, we have the same approach.
So, and normally the PhD student choose the secondment, or it's already prepared?
That's a good question, because how do the ESRs select their secondment place? At the beginning of the project, when we submit the proposal, the PIs involved, we make a plan, and we basically think, I will have a student doing this project, and these are the interesting sites where he should visit and have interaction with. But when you hire a person, you have to take into account that he might have different interests. So you basically discuss their interest, what is their career development plan. We have to take care of that. They have to basically like what they are going to do, and they might have preferences. So it's possible that they change it according to the plan that we do with them once they are hired.
Okay. One of the very important goals for this TERAOPTICS project is to prepare this early stage researchers to be good qualified and to be ready for the future. And you mentioned also in this secondment the networking, which is also another important parameter. What do you think about networking for academia in general?
Well, the networking is fundamental. That's why we have conferences. It's one of the places where you do networking. You come here, you discuss, you go to the talks and see what other people do, and that's vital in academia. We are not the masters of anything. We learn from each other, and the secondment is another dimension of this networking, because when you are on site, you actually know the people much deeper, because they have to teach you what they are doing, what they are working, and it's a more close relationship. And sometimes you even learn new techniques that are complementary to what you do, and that's fundamental, because you cannot do something on your own. You always have, in academia, you have to compare and contrast what you do with what others do. So it's fundamental.
Okay. Before we finish, actually, as a worker also in this association, in this domain of terahertz, I'm wondering, you are very expert in this domain. What is your expectations for the terahertz technologies for the next maybe 5 years? Where do you see this domain is going? Which challenges we may face?
Well, that's a good question. I think about terahertz, there has been said a lot of things, good and doubtful, but I think it's a gap. The technology in the terahertz range is still developing, and we don't know the full potential that this technology may have to disrupt the way we do things. We are all in radio waves have been evolving. Higher and higher areas of the spectrum have been reached and conquered, and we are finding uses for them every day. And with terahertz, one thing that was said today in the NetEracom session was that it will change our lives because it will not just enable communications, it's going to enable many other applications, and some of them is in sensing. And sensing means biosensing, it means high resolution radar, so the possibilities are still in the imagination, but we will be realizing them. And I think it's really exciting to be at the moment when we are discovering all that terahertz can do. And I think we are now at the moment where we can start realizing these applications. So I think there is a lot of potential.
So it's maybe the time where we start going higher from component development to build maybe more systems level terahertz.
Yes, but the good thing about terahertz is that it doesn't. It's not just the components. It's components. It's affected by materials. It's affected the high precision that you need. The very thin. We are working with very thin materials, with a mixture of materials. We still don't know if it's going to be photonics or electronics, or there will be a combination of both. So I think there are so many interesting challenges to solve that is what makes this really interesting topic to work on. It's really, I think, it's the right moment to be in the terahertz field.
Okay, thank you very much. Actually, at the end, I would like to thank you. It was my pleasure to have this interview with you. And,
Thanks to you.
Thank you very much.